Hi and welcome to Geeks for Geeks. Let us understand the problem union find. In this problem, we are told to implement disjoint set union. Now, there would be two incomplete functions, namely union and find, and we need to complete these functions. Now, before moving forward, let us first revise our concept for disjoint set union. Now, in disjoint set union, suppose we are told that we have 4 queries and we have NS5. So what we do is, we would first take the screenshot of this and then that would be more feasible. So now what we would do is, we would first make an array of parent. Okay, so let us do it. And then let's start enumerating the indices too. 0, 1, 2, 3, 4, 5 and 6 itself. Now let us take this copy of this and let us have this. So now let us start this. So we have n is equals to 5. So initially this one would be the parent array and this one would be the size array. So what we do is, initially we make every parent of itself. So 0 is a parent of itself, 1 is a parent of itself, 2 is a parent of itself, 3 is a parent of itself, 4 is a parent of itself, 5 is a parent of itself, 6 is a parent of itself. So size would be 1, 1, 1, 1, 1, 1, 1. So now we would draw the same thing here. Like we have 1, we have 2, and we have 3, we have 4, and we have 5 itself. So that it would be easy to visualize also. So initially everyone is a parent of itself. Now we are told that we need to do the union of 1 and 3. So we would take out the parent of 1. The parent of 1 is pointing to 1 itself. So whenever we get pointed to the value which is the parent of itself, we stop there. Okay. Translating the same in Hindi is, suppose हम लोग जाएंगे 1 के पास, वो अगर 2 के पास भेजता है और 2 का ही पैरेंट है, दैट मीन्स हमें वहाँ स्टॉप होना है और हम तब तक आगे जाते रहेंगे जब तक हमें कोई ऐसा वैल्यू ना मिल जाए जो खुद का पैरेंट ना हो. ओके, फेयर इनफ. सो वन पैरेंट ऑफ 1 इज 1 एंड पैरेंट ऑफ 3 इज ऑल्सो इक्वल्स टू 3 itself. Then what we would do is, as the parent are different, that means they belong from different component. Now what we would do is, we would check the sizes 1 and 3. So now this is a very important concept. So let us first see the reason for this. So suppose we have a large tree. Okay, we have a large this like structure, and then we have this structure. So which is more feasible, making this as the parent or making this as the parent? So now we can see that if we make this as the parent, this one as the parent, then the length of the tree would increase. Okay, and if the height is increased, and suppose this value is 3, this value is 4, this value is 5, then 3 would tell us to go to 4, 4 would tell us to go to 5, 5 would tell us to go to 1. So if the height is small, then finding the parent would be taking less time. That is why, to maintain the height, we merge the smaller trees into larger trees. Okay, fair enough. This is what we do. So size of 1 and 3 are same basically. So what we would do is, we would make either of them as parent. So I would just make 1 as the parent. So 1 is the parent of 3. So 3's parent would change to 1. And the parent, which is the parent, size of the parent would increase. So 1 plus which is getting merged. So 3 is getting merged to 1. What is the size of 3? 3 size is 1 and its already size is 1. So 1 plus 1 would make it to 2 itself. The first query is now processed. Now we can see that we need to tell if 1 and 2 are connected or not. So we go to 1. 1's parent is 1 only and 2's parent is 2. Both of them are different. That is why the value of them is 0. They are not connected. Then we need to do the union of 1 and 5. So 1's parent is now equals to 1 and 5 parent is also equals to 5. Then we go to 1. 1 size is 2 and 5 is 1. So 5 would merge into 2. Why? Because would smaller would merge into larger. So 2 plus the size of 5, that is 3, because the parent size was increased. And 1 is the parent of 5. So 5's parent would now change to 1. Now we need to tell if is connected 3 and 5. So what we would do is we would go to 3 and ask for his parent. 3 is telling me that to go to 1. We go to 1. 1 is a parent of itself. So I told that when we get the parent as itself, we would stop. So 3's parent is now equal to 1. And then we go to 5. 5's parent is also pointing me to 1. 1 is a parent of itself, so it would be 1 itself. Both of the parent are same, so the output is equals to 1. So now, let us first try to implement the function find. So in the find function, what are we basically doing? We are going to the value if the current index, so let us first discuss about the find value. Okay, now let us first visualize this also. So I would just take up this all and let us visualize this so that it would make more sense. Okay, so now what we do is we are telling that we need to do the union of 1 and 3 itself. If we do the union of 1 and 3, then they are this. Is connected 1 and 2? No, 1 and 2 is not connected. Then we need to do the union of 1 and 5 itself. So 1 and 5 is now done the union. Now we need to say that if 3 and 5 are connected or not. Yes, we can see that 3 and 5 is connected. That is why the output is 1 and that is why the output is 0 itself. Now let us discuss about the find function. So in the find function, we saw that suppose 5 is pointing to 1, 1 is pointing to itself only. So we keep moving forward till the value of the index and the value in the array is same. So what we would do is we would design the find function that this would return me the integer value. So we can do this and we would say find root, and then we have the int I. We want the parent of I itself. Then we have the parent array and then we have the rank array. Okay, fair enough. Then we go down. So while I is not equal to pair of I, then we need to say that I is equals to pair of I. That tell me where I need to put. मतलब हम लोग क्या करेंगे ना, अगर इंडेक्स और वैल्यू सेम नहीं है तो वो जिस वैल्यू में रीडायरेक्ट कर रहा है, अब हम लोग उस वैल्यू में जाएंगे. अब उस इंडेक्स में गए, वहां भी अगर रीडायरेक्ट कर रहा तो हम लोग जाते रहेंगे जब तक वो दोनों वैल्यू सेम ना हो. We keep moving forward till the value of the index and the value in the array is same. And after this, we would have that I is equals to parent of I. Then only this condition would stop. So at this point, we need to return the value of I itself. Okay. Now, let us discuss the union one. Okay. So let us complete the is connected one because it is very easy. So what we would do is we would say that we said int parent 1 is equals to find root of x with the parent array and the rank 1 array. So this is done, and then int p2 would be the same, that find root and then y's parent with the parent and then rank 1. So return, okay, so I would just write it simply that if p1 is equals to p2, then we would return 1 that they are connected, else we would return 0. Or else what you can do is return p1 equals p2. This would do the same thing in shorthand. Okay, fair enough. Now we need to code the union function. So what is the union function? What we do is we find the parent of this one and this one. If both are equal, that they belong from the same component, then there is no point in joining them. So let us first code this and then we would move forward. So we need to find the parent of A and B, and we can directly edit the value of A and B because the value A and B is not required when the parent is required. I would just say find root, and then we would pass A with pair and then rank 1 itself. Then we have B is equals to find root and then B and then pair and then rank 1 itself. So if A is equals to B, then we say that simply return from this point, and that is not required. Now what we do is we say take out the size of them. The size which is larger, we make it the parent and we increment the size. This is what we do. Okay, and if both are same, we can do either of them. So what we would say that if rank 1 of A is greater than or equal to rank 1 of B. Okay, if this is the scenario that A is greater, then first rank 1 of A plus equals to rank B. That is, A size was increased because that is the parent itself. Okay, now we move forward and we would say that parent of B is equals to parent of A or parent of A or just A itself, because A is the parent of itself. Whatever be the scenario, it is the same. Else we would just do the opposite, that rank 1 of B plus equals to rank of A, because this time B is greater, and then parent of B is equals to A. Okay, now this is done, and then we would return from this point. Then let us just simply check if we are getting an AC or not, if we are getting correct or it was a sample test case or not. Okay, now let us check this. Okay, we are getting a correct output for the sample test case. Now let us submit this and see if we can get an AC or not. No, we got a time limit exceeded error. So now why do we receive this? So now to see more on this, let us take up this find root 1. So in this find root 1, we need to see. So I would just tell you a test case. Suppose this is 1, this is 2, and this is 3, and this is 4, and then this is 5 itself. If this is the scenario, then 4 would be the parent of 5, 3 would be the parent of 4, 2 would be the parent of 3, and 1 would be the parent of 2. And this type of tree is known as skew tree. This condition would occur when the value is in the form of skew tree. So if we start finding the parent of 5, then it would go to 4, it would go to 3, it would go to 2, and it would go to 1. And in the worst scenario, this find root time complexity is big O of n. And the intended time complexity of find root is log n. So why do we have this? So now to optimize over this, what we do is, listen to this very carefully. When we iterate once towards the far away, then when we come down, we would say 2, your parent is 1. 3, your parent is 1. 4, your parent is 1. 5, your parent is 1. This is what we do. So एक बार अगर हमने iterate करके पता लगा लिया कि हमारा सबसे almighty parent क्या है, then in the process of returning back, we start assigning the values also, so that next time we don't need to iterate and we need to go up. This is the issue here. So what we would do is, we would have change to recursive. What we would do is, if I is equals to pair of I, then we would say that we need to return it. Okay, fair enough. Then what we would do is we would change the value also. It is pair of I. If the value is not if it is not equal to the parent of itself, then we would assign that in the process of returning back. So what we would do is pair of I is equals to find root of pair of I. We would just pass it recursively. Then we would have it pair, and then we would have rank 1 itself. So now the parent of I is assigned to the designated place itself, so that next time we don't need to move her. Now the value is saved in pair of I, so we can just return I, or so we can just return pair of I itself. Okay, now let us compile this and see if it is correct or not. And yes, it is correct for the sample test case. Now let us submit this and see if we can get an AC or not. And yes, we got an AC. This is because this optimization travels up the skew tree only once, and next time when we ask for the parent of 5, it would give us the value in constant time. When we ask the value of 4, it would give us in constant time. And each time the upper value is changed, we need to think about it. So that's it for today. Thank you and have a nice day.